B class. So if you try to look at f at A, it is at this location. It's on the negative y-axis. And then f at B class, it is on the positive y-axis. Since they are on different axes, right? I mean, the other is above the origin, and then the other one is below the origin. We are sure that the two are of opposite sides. So this is a negative value, and this is a positive value for the function values. So we say that there exists a value C such that f at C is 0. Look at that, 0. 0 is inside the two function values. It is said from the theorem that we can look for a value of C such that f at C is equal to 0. So 0 is inside the function values. It's an intermediate value. 0 is an intermediate value. So it's the intermediate 0 theorem. So it's a consequence again of the intermediate value theorem. Okay. I think one more theorem. A at B. Oh, of course, because it's an interval. Weird na, magkakaroon ka ba ng interval na ang A, yun rin yung B? Wala na yung interval, di ba? At a specific point na yun. When you say it's an interval, you have other numbers in between. So A should not be equal to B.
Ano ba yung sige?
A, end yan. End.
Maaari lang naman.
Sorry. Ano ba yung nakasanay mong end? This one? Oh, sige, sorry. Di ba dapat ganun yun?
Yes.
Sorry. Oo nga, sorry na. Ganun. Last theorem. Squeeze theorem. Na-squeeze naman yung function natin. So, suppose that you have three functions. Diba? Para yung isa may squeeze. Kailangan may gitna. So, you have three functions, f, g, h. They are defined inside the open interval I. It's also possible that it's not defined at A itself. Wala lang. Kumbaga, ang sinasabi lang dito, it also says that it can be, say, discontinuous at A, pero removable type only. So, if G is a function that is less than or equal to H, but is greater than f of x, for all x inside the interval, for which x is not equal to A, and then if we also suppose that the limit of this function f exists at A, which is also equal to the limit of the function of h as x approaches A. So, if the two limits are equal, therefore we say that the limit of the middle function as x approaches A is also L. Ulitin ko ha. If the limit of the functions here, okay, h and f, they are both equal to L. And L, letter L. It's a number. Basta a number L. And this is also, the limit of h as x approaches A is also L. Then we say from the squeeze theorem that the limit of the function g should be also equal to L. Kaya na-squeeze siya, di ba? Now, bakit natin sinabi dito, except containing A, except possibly at A itself? Because we know that the limit of the function, diba? When we talk about the limit of the function x, as x approaches to A, we do not consider the function value of the function at A. Diba? So this can exist, this can also does not exist, right? So we say, posible at A, pero except possibly also at A. It's not continuous, it's not defined. So, example, yan. Ito na. Ta-da!
Okay.
may sound effects pa, no? So, say we have these two functions here. F, this is G, and this is H. Take note that the H function here is the greatest of all of the three. And then G is just a middle function. And then it is also greater than or equal to f at x. As long as x is not equal to 2. How do we verify this? We can get arbitrary values class. Say 3. Substitute it here.
Sino mas malaki?
Diba, you'll get a value for that. Substitute it here, also at G and F. You would notice that H will always give us a value that's the largest of all of the three. And the F value is the smallest. And G is the intermediate one. So we were able to write this inequality.
Is it possible that if we change the x's, the arrangement will also change?
No.
Is that possible?
No. As long as x is not equal to 2, this function is defined gx. Okay, so if we get the value of the limit of the function as x approaches 2 plus, substitute 2 here, what happens? It is equal to 3. Right? It's equal to 3. Okay, it's equal to 3. And then what's the value of the function here? The limit of the function, h, as x approaches 2, substitute it again.
3.
It's also 3.
Therefore,
So therefore,
It's
the limit of the
continuous.
function g as x approaches 2 is equal to 3. If you're not convinced, you can do direct substitution also, right? You can just cancel out x minus 2. What happens? It's 2 squared minus, right? Minus 12 plus 7, that's also 3. O, diba? If you know the theorem, you don't need to analyze the intermediate function. You
So
just
that's the
take,
right
therefore, by squeeze theorem, the limit of g is also 3. So it's also applicable when you're given this type of question here, wherein the g function, really, we do not know the value of g. Look at this. The absolute value of g sub x minus 2 this is a number that is less than or equal to 3 times the quantity x minus 1 squared for all x. You use the squeeze theorem to get the limit of the function g as x approaches 1. So how to use the squeeze theorem? You need to get a larger function and a smaller function, wherein g is in between the two functions. And then check the limit of the upper function and the lower function. If the two are the same, therefore g takes that limit likewise. Okay, so since this is an absolute inequality type of equation, you can get rid of the absolute value as long as this one, the expression g sub x minus 2 is a number lesser than or equal to 3 times the quantity x minus 1 squared, and this is greater than negative 3 x minus 1 raised to the set of 5. But this is a fact in algebra. And then you can add the 2. Because you only need to get the value of the function of g, not g sub x minus 2. So you can add 2 on both sides of the inequality. Okay? That's one. And then this would cancel out to 0. Afterwards, we now get the limit of the function here. Hopefully, the two numbers are equal with each other. So if you want to get the limit, it has to be on all sides of the inequality. So what's the limit here as x approaches 1? Substitute. It's 2. How about at the upper function? It's also 2. So therefore, we say the limit of g is also 2 without knowing the exact value or the exact expression for g. So this is the advantage of using the squeeze theorem. Amazing, right? Last 7 examples. Time check. It's 11:10. Can we continue this?
Sige lang po.
No problem. Kaya,
Oh, sige, kaya. Just give me 5 minutes of your time. And then I will have a review on Thursday, 8 o'clock. So say if you come 8:30, goodbye na yung mga tips ko, di ba? Okay, so you just need to memorize this. This has been proven using the squeeze theorem, but I will not discuss it anymore. So the limit of sine t all over t as t approaches 0 is equal to 1. How to verify if this is correct? You can use your calculators at home. You just get 0.0001. Substitute it here. You'll get a value that's equal to 1. And then likewise from the left, negative 0.001. So the 2 approaches to that same value and that's equal to 1. So that's why we have here equals 1. That's how to verify using the calculator. And then likewise, it is also for this one. Limit of 1 minus cosine t divided by t as t approaches 0, that's equal to 0. You can also use your calculators to verify that. Pero analytically speaking, how we prove we use epsilons and delta? Pero wag na. Okay. So the sine, cosine, tangent, cotangent, secant, cosecant, they're always continuous on their domains. And the domain for a sine and cosine function is the set of real numbers, right? You can substitute any value for x there, for your angles. And then you get something like an answer for sine at that specific value. So it's continuous on their domains. So say if you want to look for the limit of this expression as x approaches 0, what you can do. So notice, this theorem is only applicable as x or as the variable approaches to 0. Other than that, you have to perform direct substitution. So for letter A, so limit sine 3x over sine 5x as x approaches 0. So it is said here that if this is t class, the denominator should be t. If this is 3x,
divided by
I should have a denominator that is
3x.
here. And then at the bottom, say times 3x, of course, right?
3x.
So it's as if I'm just multiplying the numerator expression by 1. I will do the same thing here.
5x.
Since this is 5x, this should be 5x, and then
By
I
5x.
should write 5x here. Now this one, I can cancel out the x here, right?
3/5.
And then the limit of this one is a sine t over t, right? This goes to 1. This also goes to 1. And then I have 3 over 5. So the answer here
3/5.
is 3 over 5. That's
Yes.
our technique. It's magic. Simple magic. Of course, the other one, if this is t, this should be t. If this is 2x, this should be 2x. For the limit of this expression to be 0. You have to follow strictly the formula. Okay,
Wow,
everyone?
very logic.
Number 2, C. So I have limit x approaches 0, 1 minus cosine all over sine x. Since this is x class, it should be over x times x. You understand?
Yes.
This one, sine x, this is x. We need to use the theorem. This should also be x. And then times it again by x. So the x here, they will cancel out. What happens?
Zero.
This one is 0.
Over 1.
The denominator is 1.
1.
So the answer in number 2
0.
is 0. Very good. It's really fulfilling to teach yung mga ganito mga klaseng bata. They're willing to learn. We have this eagerness to listen. It's nice to be a teacher. Number 3. How about that? It's tangent squared. So you need to redefine it in terms of sine and cosine because we only know the formula for sine and cosine. So you have limit, it's 2 tangent squared of x divided by x squared as x approaches 0. So, what is tangent squared?
Y
It's
squared.
2
Sine
sine squared
Squared.
x all over
Cosine
cosine squared x all over
x squared.
Pangit na yung whiteboard.
Ang daming over.
Maraming over na. Let's see. So this is limit. What happens? This is 2
2 times sine
sine
squared.
x sine x.
Yun.
Para makita, di ba? For you to be able to see that we only need sine x. And then at the denominator, what
Over x
happens?
squared.
Over x.
I can also write this one, x here, x squared, on top. Yes or no?
Yes.
Yes, yes,
Because I
yes.
can proceed to multiplication and get the reciprocal of x squared. So this is times 1 over x squared. So I can put x here beside cosine,
Yeah.
square of cosine. So I can just put 1x and x there because I need those. And then for the other one, it's cosine x squared, like that. And then we now get the limit of the function as x approaches 0. This one, it is 1. The other is also 1. What's the limit of this function as x approaches 1? It so happens it's defined at x equals 0, right? The cosine. So it's 1. Substitute. Cosine 0
2.
is 1.
It's 2.
So it's 2 over 1.
It's
The
2.
answer is 2.
Yes.
I want you to answer 5, 6, and 7.
Assignment.
Before assignment again. And, sige, ako muna sa 4. Ako na lang muna sa 4. Para ating kapatid. Number 4, limit. It's because I have a class at 11:30. X approaches 0. So this is x over sine 3x. So, what will we do here? So this is sine 3x, it should be 3x here. And then times 3x, it's as if I just multiplied it by 1. And then, this is 1, right? And then x will cancel out. What's left?
1/3.
It's 1/3. Very good. That's the answer. Oh, okay. We use algebra. I'll see you on Thursday.
Thursday.
Our quiz will start at exactly 9 o'clock.
Ano ba yung coefficient ng cosine squared?
1 minus yan. 1 minus. Sino ang late ulit? Late comer? Wala? Ako ba? Ang late comer? Can somebody erase this for me?